Hi everyone, this is Dr. Swaminathan Yasyam. Now I am going to take another important topic, signal flow graph, SFG. So last class we discussed about the block diagram reduction technique, important 7 rules, and following with the rules we just apply the rules into two different block diagram reduction techniques examples, and we analyze the solution. So next, signal flow graph, introduction about the signal flow graph, the basic elements of signal flow graph and the examples of the signal flow graph, and conversion block diagrams into signal flow graph. Following with the examples, we'll discuss the important Mason's gain formula, then summarize. So this is the outline of today's class. And again, the signal flow graph, that is a graphical representation of the signal flow graph, algebraic equations that is defined. The block diagram reduction process, it takes more time for complicated system. So to overcome this drawback, use signal flow graphs that is done in the calculation of the transfer function is just by Mason's gain formula for any reduction techniques. And the basic elements of signal flow graph: node, input node, output node, mixed node. Node means that is represents either variable or signal. There are three types of nodes: input, output, and mixed node. Input node means that is only the outgoing branch. Output node means only the incoming branch. Mixed node means both incoming and outgoing branches. So the forward path that is defined, it's a path between the input node to the output node, does not cross any node more than once. Individual loop means it is a closed path that starting from one node and after passing through the graph arrives at the same node without crossing any node more than once. Non-touching loops means if a loop doesn't have common node, then it's said to be non-touching loops. Example, you can say the node y1, y2, y3, y4. y1 and y4 are the input node and output node. So y1 is the input node, y4 is the output node. y2, y3 are the mixed nodes because it is having input and as well as output. So branch is a line segment which is joins two nodes. So it has both gain and directions. So A, B, C and minus D. Examples: y2 is equal to a1 to y1 plus a4 to y4, and y3 and y4, y5, y6. These are all the 6 different nodes. Just having the examples: y1, y2, and again a42 means that is gain, a42 that is from y4. So we leave y3 and y5, y6. Again y2, a23, y2, because a23, y2 means from y2 to y3 only a23, because a23 denotes 2 to 3. So 2 to 3 the gain a23. And again y that is a53 means from 5 to 3 that is the gain. So 5 to 3 the arrow mark defines a53. And another thing, y4 is equal to a34, y3 means 3 to 4, that is y3 to y4 we are having the gain a34. And again the another step, that is y5 is equal to a45 y4 plus a35 y3, that it means a45 again the a35. And again the step 5 we are using y6 equal to a56 y5. And again that's another example, step 6 also we are using. Following with the activity, we will discuss the conversion from the block diagram into the signal flow graph. So representing the summing points and takeoff points in the blocking nodes in the signal flow graph. So represent the blocks of the block diagram, that is called as a branches. Represent the transfer function inside the block, that is called gains. Connect the nodes as per the diagram. So look at this. These are all the block diagram. We just convert the block diagram that is into the signal flow graph. So look at this, R of S and Y of S is the input and output. We just convert based on this given formula. So these are all the things we just convert. And again G1, G2, G3 are the gains. And again look at this, that H1, H2, H3, the feedback loops are that is the loop, that is loop we define. Okay, so these are all the advantages. That is very simple formula. So using the Mason's gain formula, you can calculate. What is the Mason gain formula? T is equal to 1 by dou summation k pk into del k. So del is nothing but 1 minus sum of individual loop gain plus sum of gain products of all possible combinations of two non-touching loops minus sum of to all possible combinations of three non-touching loops, up to it goes vice versa. So the minus plus it goes up to vice versa. Del k is nothing but the k forward path, that is called the del k. So T is equal to 1 by del summation k into pk del k. That is the Mason's gain formula. So that is a transfer function. So let us know the discussion about the Mason's gain formula. So n forward path in the Mason's gain formula group. So we need to find the transfer function of the system, that is using the Mason's gain formula. So it represents the values and summing points and takeoff points as a nodes, and blocks is nothing but branches, and the transfer function inside the blocks, that is called the gains, and connect the nodes as well as. So these are all the Mason's gain formula. Once again I tell you, C of S is the output node, R of S is the input node, T is nothing but the transfer function between R of S and C of S, Pi is the ith path of forward gain. So the formula del is equal to 1 minus sum of individual loop gain, and again, so individual, first single individual, that is 1 minus sum of individual loop gain plus sum of gain of two non-touching loop, and again minus minus sum of gain of products, that is three non-touching loops. So these are all the Mason's gain formula to find the transfer function in the signal flow graph. Thank you.